Hey guys, today's lesson is on section 8.5 called the greatest common factor, also known as the GCF. The GCF, or the greatest common factor, is the largest number or expression that goes into all numbers or terms evenly. As you can see, problems 1 through 6, we have a pair of numbers, and we're looking for the greatest common factor, or the largest number that would go into both. For example, problem number 1, I know that 2 would go into both 16 and 20 evenly. However, we're looking for the largest number that goes into both 16 and 20. A good tool that you could use for this section is a calculator in which you could guess and check numbers to find the largest one that goes into the pair of values, or 16 and 20. Another option is you could start with a factor or a number that goes into both of the numbers and divide it. For example, 16, I know 2 goes in evenly to both 16 and 20. And when you divide, 16 divided by 2 is 8, 20 divided by 2 is 10. The question you should ask yourself now is there a number that goes into 8 and 10? If not, 2 is the greatest common factor. If there is a number that goes into 8 and 10, we're going to continue dividing until we get a pair of numbers that a no number would go into both of them. So, for example, is there a number that goes into 8 and 10? Yes, there is. 2 also goes into 8 and 10. So I'm going to divide again. 8 divided by 2 is 4. 10 divided by 2 is 5. Is there a number other than 1 that now goes into both 4 and 5? No, there's not. How am I going to find the GCF, or the greatest number that goes into 16 and 20 using this method? Well, since I divided by 2 first, and then I divided by 2 again, we're going to multiply those two factors, 2 times 2, in order to get our GCF. The largest number that goes into both 16 and 20 is 4. Some of you guys could have guessed and checked and found that answer on your calculator or in your head, or you could use this procedure that I'm showing you. Problem number 2 is pretty similar, such that I know that 5 goes into both 25 and 100. However, we need to check to see if it's the largest number that goes into both. So what I'm going to do is divide both of the numbers by 5. 25 divided by 5 is 5, 100 divided by 5 is 20, and ask myself, is there a number now that goes into 5 and 20? Yes, there is. That number is 5 again. 5 divided by 5 is 1, 20 divided by 5 is 4. Is there a number that now goes into both 1 and 4? No, there's not. Since I divided by 5 first, and then divided by 5 again, what we're going to do is multiply the numbers we divided by to get the GCF. 5 times 5 is 25, which tells me 25 is the largest number that goes into both 25 and 100. Again, some of you might not need to go through this procedure to find the GCF, but it's always here for you guys to use to check to see if you found the largest number. Problem number 3. 2 goes into 48 and 60, but I also know that 4 goes into 48 and 60 as well. Let's see if 4 is the greatest common factor by dividing both of them by 4. 48 divided by 4 is 12, and 60 divided by 4 is 15. Ask yourself, is there a number that now goes into 12 and 15? Yes, there is. That number is 3. 12 divided by 3 is 4. 15 divided by 3 is 5. Is there a number that goes into 4 and 5? No, there's not. So the procedure now ends. How am I going to find the GCF, or the greatest common factor? I divided by 4 first, and then I divided by 3. So what we're going to do is multiply those factors, 4 times 3, to get 12. That tells us that 12 is our GCF. It's the largest number that goes into both 48 and 60. What I'm going to ask you guys to do is pause the video, try number 4, 5, and 6, then go ahead and play the video back to check. Here's your answer for problems 4, 5, and 6. The GCF, or the largest number, for number 4 that goes into 27 and 72 is 9. For number 5, the largest number, or the greatest common factor, that goes into 32 and 100 is 4. And lastly, the biggest number that goes into 22 and 55 is 11 for problem number 6. Moving on to the second half of our page of finding the GCF, we now have expressions that have variables in. So we're going to find the biggest number that goes into both 10 and 30 for problem number 7, and then we'll talk about what they have in common in terms of variables. The biggest number that goes into 10 and 30 is 10, in which there's also more that those two terms have in common. Since they both have the variable x, our GCF for problem 7 is 10x. Similarly, problem number 8, what's the biggest number that goes into 4 and 8? That would be 4. In addition, they both have a variable in common. D squared tells me that it's d times d. The first term technically has 2 d variables in it. The second term only has 1 d variable in it. How many do they both have? Do they both have 2? No, because the second term has only 1. Do they both have 1? Yes, they do. Therefore, the GCF for 8, what's in common between those two terms is 4d. Our GCFs are now expressions since we're adding variables into the terms. Problem number 9, the biggest number that goes into 24 and 30 happens to be 6. What else do these two terms have in common? They both have a d squared. Our GCF for number 9 is 6d squared. Problem number 10, biggest number that goes into 5 and 10 is 5. Both terms have an x, so our GCF is now 5x. However, both terms don't both have a y or both have a z, therefore they are not in common. Our GCF for number 10 is just 5x. Problem number 11, the biggest number that goes into 12 and 24 is 12. The first term has 2 x's, the second term has 1, so they have 1 in common, and they both also have a y. The GCF for number 11 is the expression 12xy. And lastly, number 12, the biggest number that goes into 14 and 21 is 7. The first term has x squared, the second term has x cubed. X squared is telling me there's 2 x's in that term. X cubed is telling me there's 3. How many do they both have? They both have 2, therefore our GCF is 7x squared. They both don't have y, so therefore it's not common and does not belong in the greatest common factor. We are now going to use the greatest common factor to factor expressions. On our second page here, factoring is expressing a polynomial as a multiplication problem. Problem number 1, we see each step in factoring a polynomial, in which the first step is to find the GCF, just as we did on our first page. The GCF for the terms 5x and 30x would be 5, since 5 is the biggest number that goes into 5 and 30. In addition, they both don't have the same variable. Step 2 is to divide both of the terms by the GCF we found. So we're dividing both of the terms by 5. 5x divided by 5 is x, while 30y divided by 5 is 6y. Lastly, we're going to answer the problem. They're asking us to factor that polynomial or express it as a multiplication problem. What times what is going to give us 5x plus 30y? And that answer is in the form of the GCF, which we know is 5 for this problem, times the polynomial we get after we divide in step 2, which is x plus 6y. Last thing we could do is just check to see if our answer is correct. What we're saying is that 5 times x plus 6y is our original expression here. So if we were to distribute the 5 times the two terms inside the parentheses, 5 times x is 5x, 5 times 6y is 30y, which is in fact our original expression. Therefore, we know we're correct. So we're going to use these steps for the next couple problems in factoring these polynomials or writing them as a multiplication problem. Going down to problem number 3, step 1 is to find the GCF. In this case, what's the biggest number that goes into both 12 and 16? I know 2 goes into 12 and 16, but there's a larger number that goes into both of them. That number is 4. In addition, both terms have an A. Specifically, the first term has 2 A's and the second term has 1. Therefore, what's in common is 1A. We're going to divide both of the terms by our GCF, 4A, and we're going to get 3A plus 4. How am I going to write my answer here? It's the GCF 4A times the expression you get after we divide. We could always double check to see if this makes sense, such that we're saying that 4A times 3A plus 4 is equivalent to the expression that we had 12A squared plus 16A. We could distribute the 4A times both of the terms inside the parentheses, and we will see that we get our original expression. Problem number 5, let's first find the GCF. The biggest number that goes into 15 and 20 is 5. They also both have an x, therefore their GCF is 5x. Let's divide both terms by 5x and start writing our answer. It would be 5x, the GCF, times whatever you get after you divide. 5xy divided by 5x is 3y. And 20x divided by 5x is 4. Last problem in the column. Let's first find the GCF of the two terms. Biggest number that goes into 12 and 40. I know 2 goes into 12 and 40, but there's probably a larger number that does. Double check on your calculator or do the procedure that I showed you in the beginning of the video, in which you'll find that the GCF, or the biggest number that goes into 12 and 40, is 4. Both of the terms have 1x, 2 y's, and 1 z. So what we're dividing both terms by is 4xy squared z, in which our answer will be the GCF for y squared z times whatever you get after you divide. 12 divided by 4 is 3. X squared divided by x is x. Y squared divided by y squared is 1. Z divided by z is 1. Plus 40 divided by 4 is 10. X divided by x is 1. Y cubed divided by y squared is y. And z squared divided by z is z. What I'm going to ask you guys to do is pause the video, try the even problems, 2, 4, and 6. Once you get your answers, play the video back to check. Here are your answers for problem 2, 4, and 6. In problem 2, we found the GCF was 4. Therefore, our answer is 4 times 4a plus b. We get the 4a plus b by dividing both of the terms in the original expression by 4. In problem number 4, our GCF is 2h. Our answer is 2h times 7g minus 9. And lastly, number 6, our GCF is x squared. Our answer is x squared times xy squared plus 1. Remember, when dividing both of the terms by x squared in problem number 6, x squared divided by itself is 1. Don't forget to record that answer. Last problem we're going to go over here is problem number 8, where there are 3 terms. So the GCF has to be the biggest expression that would go into all 3. The largest number that goes into 12, 20, and 32 is 4. And each of the terms have an x in common, nothing else. All 3 of the terms have to have the same variable for it to be in the GCF. Our answer will be 4x times whatever we get after dividing each term by 4x. The first term, 12ax cubed divided by 4x, is 3ax squared. The next term, 20 divided by 4, is 5bx. And lastly, 32 divided by 4 is 8. X divided by x is 1, so we would just be left with the c. Please let me know if you guys have any questions on the lesson, and I'll talk to you soon.